Hello and welcome to this tutorial on wave interaction. Specifically in this part one, we're going to look at wave reflections, or in other words, how waves behave when they interact with the boundary. So we're going to use this simulation today to look at that. First, let's just review some of the wave characteristics. So one thing we know is that waves are caused by a vibration or an oscillation. So the wave in this picture is coming from this object over here, which vibrates and then sends a pulse, a wave pulse down this string. We know waves have amplitude, so that is their displacement from equilibrium. This would be the crest and this would be the trough of the wave. We know that they have a wavelength, so the wavelength is from the beginning to the end, so this would be one wavelength. In this case, we're measuring from equilibrium to equilibrium, or one full cycle, but you could measure from crest to crest or trough to trough, any 2 points as long as you go through one full cycle. We also know waves have frequency, so we can measure how many of these pulses were, or how many full cycles there were in 1 second and get its frequency. And finally, waves have velocity, and what you'll see is that the velocity of this wave is in that direction. Okay, so let's reset this and look at what happens when we send a wave pulse. So you can see that it's moving. We're going to reset this. We're going to actually, for simplicity's sake, just use half a wave, and we're going to send that pulse through here. But first we need to look at what the type of boundary is. So there are actually two types of boundaries that we're going to look at. The first is called fixed. It is fixed because at the end the boundary cannot move. So in this case, what we have on the end is a knot, and this knot prevents the string from moving up and down, so it is a fixed or not free to move end. So let's send this wave pulse, and you can see that this wave pulse has a negative displacement, or its amplitude would be some negative value. And then what I want you to observe is what happens to the wave pulse when it hits the boundary. So we see as the wave comes back, so now its velocity is this direction. It is now upright, or has a positive amplitude, whereas on the way in, when its velocity was going in, the wave had a negative amplitude. So what we can say is that when that wave interacts with a fixed boundary, the wave is reflected with the opposite displacement, or another way to say that is the wave is inverted. So do this way. What if we sent this a wave pulse with a positive amplitude and it reflected? What would happen? When it came back, it would have negative displacement. So basically, when a wave interacts with a fixed end, it becomes inverted. So let's reset this, and now instead of a fixed end, I'm going to change it to a ring. So I'm not sure how well you can see this, but what actually it is instead of being a knot, it's a ring that would allow this fixed end to move up or down along that pole, which means it is not fixed. This is called a free boundary. Okay, so again, we're going to send half a wave, and you can see it has negative displacement again, or a negative amplitude, and we'll watch what happens. And as it reflects, it maintains the amplitude that it came in with. So it came in with a negative amplitude, and it came out with a negative amplitude. So the key here is that, or to recap, when you have a fixed boundary, waves reflect inverted, or in other words, if you had positive going in, it would be negative going out, or negative in, positive out. With a free boundary, waves reflect with the same displacement that they started in. I hope this tutorial helps. You can also find more information on this in the text.